I've already explored tiny homes, earthships, passive homes, and also modular homes as more efficient and sustainable alternatives to traditional houses. But what if you could build a home or apartment building that's not only fire-resistant like concrete, but also more efficient and sustainable than conventional homes? Let's explore hemp building materials and their benefits for achieving a low-carbon future. Could hemp blocks be better than concrete? Alongside renewable energy and EVs, sustainable homes are crucial for driving our world towards a net-zero future. On a global scale, residential homes and apartments account for about 21% of carbon emissions, where heating and cooling make up a big piece of that pie. However, the manufacturing and building process, as well as traditional construction materials like concrete and metals, generate carbon emissions and waste. Concrete is the most used building material around the world and contributes about 8% to the world's CO2 emissions. Steel contributes an additional 11% to global carbon emissions. In order to build more sustainable homes and map a pathway to a net-zero future, natural and eco-friendly building materials are being developed. A few examples are straw bales, rammed earth, recycled plastic, bamboo, mycelium, and many more. Due to its resilience, insulating property, fire resistance, low carbon footprint, and its lower density, the next eco-building material may be hemp. When someone brings up hemp, your mind might jump straight to marijuana. Hemp is a variety of cannabis sativa that only has a very small portion of THC, which is the substance that causes psychoactive effects. Marijuana flowers can contain 15% THC on average, and when extracted, that level can reach up to 90%. Hemp, however, only has about 0.3%. It's a very versatile product that can be used for clothing, producing seeds for oil and eating, ropes, food, and more. Even so, it's had a bit of a turbulent history. Hemp has been harvested for thousands of years, with evidence of its use going back to 8000 BC in Asia. Around 600 and 200 BC, hemp was used by Europeans to make ropes. By 100 BC, the Chinese started to make paper out of the plant. In the 1600s, Americans had discovered the benefits of using hemp for making food, ropes, shoes, and clothes. After the repeal of the prohibition of alcohol in 1929, marijuana was pointed to as a devil drug. Even though hemp had nothing to do with marijuana, it was caught up in the early war on drugs. In 1937, the U.S. approved the Marijuana Tax Act, charging cannabis dealers and making cannabis illegal. While hemp was still technically legal, the requirements around importing and exporting hemp made commercial production in the U.S. less economical. In 1971, after years of its forbidden use, the UK began issuing hemp licenses for farming, provided hemp was grown for non-drug purposes. The United States began to issue licenses in 2007. It took until 2018, with the passage of the U.S. Farm Bill, that the U.S. government defined industrial hemp as a federally legal plant, as long as it doesn't contain more than 0.3% THC. All of that legal drama held back any further research or development into hemp for practical use in the UK and the US. In France, however, there was a push to find a suitable alternative for rotting wattle and daub in medieval timber-framed houses, and hemp had some real advantages. Since then, making building materials out of hemp has been spreading worldwide as a more sustainable alternative to traditional building materials. Perhaps one of the most investigated products is hempcrete, which has some similar properties to concrete. Hempcrete is a composite made by combining water, lime, and hemp stalks inner core. The lime component is made up of air lime, which is designed to accelerate the setting process. This combination results in a flame-resistant, pest-resistant, moisture-balancing, and strong, biodegradable insulator. In addition, hempcrete is also reusable if milled and rehydrated. Hempcrete is suitable for constructing self-insulating walls, roofs, and screeds, and it's adaptable to either new construction or renovations. Typically, hempcrete is cast around a structural frame made of wood, metal, or concrete when building walls. It can be used to repair damaged cob walls and half-timbered walls. While these are nice capabilities, when we're talking about sustainable homes, one of the biggest things to look at is insulation value, or the difficulty for heat to pass through it. That's where hemp takes a commanding lead. Homes built with hempcrete can achieve fantastic thermal performance. While concrete has thermal insulation from 0.62 to 3.3 watts per meter Kelvin, hempcrete's value ranges from 0.06 to 0.07 watts per meter Kelvin. The lower, the better. A lower value means less heat can pass through the hempcrete than concrete, keeping a house warmer in the winter and cooler in the summer. You might be more familiar with R value, which is basically the material's resistance to conduct heat. The higher the R value, the greater the insulating effectiveness. For concrete used in floor slabs, for example, the R value ranges from 0.1 to 0.2 per inch of thickness. So a 6 inches thick slab would have an R value between 0.6 and 1.2. On the flip side, the R value for hempcrete ranges from 2.4 to 4.8 per inch. So that same 6 inches slab would have an R value of 14.4 to 28.8. That's kind of a crazy difference, which means hempcrete will save money on a building's energy bill and maintenance costs over the product's entire lifespan. For a quick cost comparison, concrete is cheaper than hempcrete, costing $85 per square meter, while hempcrete, on average, costs $135 per square meter. But hempcrete can provide from 50% to 80% in energy savings, mainly with heating and cooling. For a real-world example, a 170m2 home built by D.B. Chandler utilizing hempcrete and a timber frame system combined with an insulating wall, ground floor slab and first floor screed had a heating bill of €300, which about $340, for 6 to 7 months of heating, which can vary depending on the year. For comparison, the heating bill for a similar-sized house would be about $1,055. Both concrete and hempcrete do something that's important to factor in. They both absorb CO2 during their life. They're both carbon sponges, but concrete doesn't offset the negatives of producing it. In 2018, each ton of concrete produced released between 0.5 and 0.6 tons of CO2. But according to an Intergovernmental Panel on Climate Change report, concrete absorbs about half of that CO2 during its life. On the other hand, hemp is carbon negative, sequestrating more CO2 from the atmosphere than is emitted during its production. 1 hectare of industrial hemp can take 15 tons of CO2 from the atmosphere, and the lifespan of hemp as a building material can last for centuries depending on the weather conditions. In Japan, for example, a hemp house built in 1698, more than 300 years ago, is recognized as a National Heritage Site. How does hempcrete stack up against concrete when it comes to strength and costs? Concrete is non-toxic when cured, fire-resistant, pest-resistant, can last for thousands of years and tolerates standing water better than hempcrete. However, a cubic meter of hempcrete can hold more than 1,300 pounds of water vapor without degrading, performing very well even in high humidity conditions. When it's raining, it can absorb the water and release it when the sun comes out again, protecting the building from moisture and not cracking like concrete does over time. When it comes to compressive strength, which is basically the resistance of a material to crushing before breaking, concrete can easily achieve compressive strengths ranging from 3,000 psi to 4,000 psi. On the flip side, hempcrete reaches much lower levels from 72.5 psi to 507.6 psi, but that can be addressed with additional supporting frameworks. However, compressive strength isn't the only measure of strength. Hempcrete is 3 times more resistant to cracking than regular concrete during an earthquake where shear loading, which is trying to tear, becomes more important. Although hempcrete is exceptionally lightweight and has excellent insulation properties, it's not as capable of being a load-bearing wall by itself. You can't build a house's foundation with hempcrete on its own. Materials like wood or steel still need to be used to create the basic structure, in addition to traditional plumbing and electrical materials. Although hempcrete has some cons, there are some newer hemp products that can make up for that. A few companies are producing hemp blocks, which are basically hempcrete-like blocks that are dry-glued or interlocked. They can be used as formwork and filler for a strengthened concrete column or beam structures, so it can be used in load-bearing walls and in fill walls. Just like hempcrete, they don't have load-bearing capacities on their own, but the integrated framework takes on that role. Just Biofiber Structural Solutions, a Canadian company, has developed a system with a composite structural frame inside each block that interlocks when stacked. That structural frame is what gives it the load-bearing capacity. It's like a giant Lego block, but one that weighs about 13 kilograms per block. I don't think you'll be getting this for your kids. They have great air and humidity permeability, can resist fire for 2 hours, and have a life expectancy of 100 years. When it comes to embodied energy and carbon sequestering, each block can take 6.5 kilograms of CO2, which means sequestering an average of 10 tons of CO2 per home. On the construction side, the interlocking Lego-style system reduces time for construction, which means saving on labor costs. The estimate is about $32 per square foot per working hour. One of their first projects, the Harmless Home, is a net-zero home in Victoria, British Columbia. This sustainable house is taking advantage of the high insulation capacity, along with rainwater harvesting, filters for potable water, a wastewater treatment plant that creates clean water, and more. Another company that's been developing a similar idea is Hemp Block, which operates in Australia and the US. Their product can be used for external and internal insulation, partitions, renovations, and can be used in load-bearing walls and in fill walls. Their products can save up to 70% on heating and cooling bills, as well as reduce construction time by up to 80%. When it comes to costs, a hemp block is about $20. According to Johan Tayson, director of Hemp Block USA and Australia, at $14 per square foot, using hemp LOCKs to build house walls is cost competitive or even cheaper than utilizing conventional building materials. The price of concrete walls varies according to the thickness and location, but Home Advisor states that the cost per square foot ranges from $10 to $60. Even with these advantages, there are a few challenges that need to be overcome in order to make it a mainstream sustainable building material. Hemp fibers are usually ready to be harvested in 2 months, but there's also a period for curing, so it's not as instantly available as concrete. Also, there aren't many builders with hands-on experience in building homes with hempcrete, as well as a lack of information and education around it. Despite that, it's inarguable that hemp has several properties that are great for building sustainable homes. There's even more I could go into, like hemp wool insulation or hemp flooring, but that's out of scope for this video. It's an incredibly versatile product. The global industrial hemp market was valued at $3.61 billion in 2020 and is expected to expand at an annual growth rate of 16.2% from 2021 to 2028. Although hempcrete can't totally replace concrete for all applications, there are several benefits to using hemp for building sustainable homes. It can provide a healthier environment for homeowners, not to mention the savings with heating and cooling, and help build a more sustainable world. Although building a home with hempcrete and hemp insulation is currently more expensive than using concrete and traditional material, the savings in electricity from the incredible insulation values can offset the upfront cost. In addition, with more companies jumping into this market, prices should lower in the coming years. Hempcrete products may not be the silver bullet to kill off our needs for concrete, but it's a very capable product that can fill a lot of different use cases. If you enjoy our video, don't forget to subscribe our channel. Comment down below, what kind of technology do you want to see in the next video?